Hey everyone, this is Dr. Walker. This is video 102C on gravitational field. This is going to be a very quick video. Just want to introduce a concept that will be very helpful, especially in physics 2. And the concept is talking about the idea of a field. In this case, the gravitational field, but in physics 2, you'll see the electric field. So the idea of a field is one way to explain the gravitational force between two objects. Up to this point, we have said, let's say we have the sun and a planet, then we know that they attract each other. There's a gravitational force between them, even though they're not in contact with each other. So instead of thinking of this planet here being attracted to the sun because of this force, what we can do is introduce the concept of a field. What we're going to say is that the sun here, this object, which we call the source, is producing a gravitational field everywhere around it. So this mass here, which is a test particle, by being within this field, this invisible field here around the sun, because it's within that field, it's going to experience that force. So it's the field from the sun that causes this test particle to experience that force. The reason that we call this planet the test particle is because we could put any planet within that field, and whatever object that you put within that field, it's going to experience that force. So the field is going to be defined as the force experienced by that test particle divided by the mass of that test particle. So we'll say that the test particle here has a mass m0, while the source, we could say it has a mass m. So this equation also explains why we talk about a test particle. You see that we divide the force by the mass of the test particle. So the test particle that we put within this field does not affect the field that is produced by the source, right? The only thing that affects the field produced by the source is the source itself. Let's take a look at it just a little bit closer. So instead of talking about the sun and a planet, let's talk about an object of mass m, or mass m0 here. This is going to be our test particle, just a little object that is near the Earth. This is called the Earth. So the Earth is going to be the source. The source is whatever's producing the field. Now technically, the test particle itself is also producing a field, but we're not looking at that field. We're looking at the field produced by the source, and then the test particle being placed within that field. So the gravitational field is the force experienced by the test particle divided by its mass. Now, what is the force experienced by this test particle? The force is g, the mass of the Earth, times the mass of the test particle divided by the distance between them. This is the gravitational force. So if we divide the mass of the particle, cancels out, we get left with this expression here. Near the Earth's surface, g equals negative g times the mass of Earth over the distance squared. R is a unit vector that points away from the source. So, since we know that the mass here is going to experience a force towards the source, the Fg is towards the source, which means that the field must be in the same direction as the force. So we know that this field here, this gravitational field, is directed towards the source. That's why we have a negative sign, just to show that it does point towards the source. If we are near the Earth's surface, then that means that the distance r between our test particle and our source here, the distance r, is just going to be the radius of the Earth. The r is going to be the radius of the Earth. So if we plug in the radius of the Earth here, we get g equals negative big G times mass of Earth over radius of Earth squared. If we plug in all of these values, these constants here, we will get the negative 9.8 that we're used to for that value of G near the surface of the Earth. It's meters per second squared here. All right, so that is the idea of a field. If you kind of understand the idea that the source produces the field and the test particle experiences a force as a result, it will really help you when we get to electric field in physics 2.